Let's integrate the function x squared y over the region D, where D is the region that is between y equals x squared minus x minus 1 and y equals x minus x squared plus 3. So we can actually just get a quick picture of what these two parabolas look like. All right, here they are here, right? So the there's this region in between, and the one that's underneath, at least for the region between, is going to be the x squared minus x minus 1. That's the one that's under, right? That's the smaller y values. The bigger y values are given in blue. And we'll just save a little time on doing all the algebra, but the x coordinates are -1 and -1 here, yeah, and then +2 there. Okay, so this is going to be x from -1 to +2, and as we just saw in the picture, at least for the region we want, x squared minus x minus 1 has a smaller y value, so that is less than or equal to y, which is less than or equal to -x squared plus x plus 3. I just shuffled the order of the terms. So let's set up that integral. Yeah, the outer integral, the final integral, the dx one, that's the one that has constants out here, right? So -1, +2. The inner integral, so y goes from x squared minus x minus 1 all the way up to -x squared plus x plus 3. And then the function we're integrating, x squared y, is listed right in there. Okay, so look, the inner integral has variable y, so we should integrate with respect to y, treating x like a constant. So yeah, 1/2 x squared y squared. We should plug in y as this, plug in y as that. It looks something like this, which is a little messy again, and we will skip the remainder of the steps because at this point this should be a Calc 1 style integral, as messy as it is. Okay, let's set up the integral of 2xy for d being the part of the xy plane between y equals sine of x and y equals 10 plus sine of x, and x equals 0 and x equals 3 pi over 2. So just for a quick picture, well, think about it. The sine curve and then that same sine curve except shifted up 10 units, x equals 0, vertical line, and x equals 3 pi over 2, another vertical line. This looks sort of like a wavy flag or something like that. Okay, here's a picture of those four equations, and we're looking at the region in here. So x is, from 0 to 3 pi over 2, okay, right? And then the y values are always stuck between sine of x and 10 plus sine of x. So if we go back, the x should go from 0 to 3 pi over 2. Y should go from sine of x to 10 plus sine of x, and we're integrating the function 2xy. Okay, so of course, if we were to actually, so the question was just to set it up. We're not even going to go through any more work at this point. So we're done. The question was set up the integral. Could we actually do the integral? Yeah, we could go through the steps. I mean, we'll just talk about it, right? The first step to actually evaluating would be to look at the inside thing, right? So I've highlighted that in blue, and we should integrate 2xy with respect to the variable y, thinking of x as being constant. This would be done by looking at the antiderivative of 2xy with respect to y. That'd be x times y squared. And then we'd have to look at integrating, so yeah, once you plug in, then y is 10 plus sine x, and you plug in also y is sine of x. We'd be looking at integrating the function x times the square of the quantity 10 plus sine of x minus x times sine squared x, and we'd be integrating that from 0 to 3 pi over 2. Now this can be done, but integrating a sine squared is just a little messy, so let's not kind of dig into the details here too much.